Every time you send a message, stream a video, or open a website, something invisible wakes up somewhere on the planet. Not an app, not the cloud, a real physical machine inside a real building, generating real power, generating real heat. The internet feels wireless and instant, but behind it lies one of the most complex industrial systems humans have ever built: data centers. And most people have no idea how deep this system actually goes. When we think about the internet, we imagine software, apps, and cloud platforms. But the internet is not magic, it's infrastructure. Massive, layered, engineered infrastructure. In this video, we're not going to talk about surface-level facts like data centers store data. Instead, we're going to peel back the layers and understand the actual system working, how data centers evolved, how they physically move data, how they survive failures, and how this hidden machinery keeps the internet alive every second. The story of data centers begins long before the word cloud existed. Early computing relied on centralized mainframes, single machines serving many users. As the internet grew, this centralized idea didn't scale. So the system shifted from one powerful computer to thousands of coordinated machines, and data centers became the factories of the digital world. At the lowest level, a data center is not about data. It's about power and heat management. Servers are useless without electricity, so everything starts with power intake. Data centers pull electricity directly from high-voltage grids, step it down using transformers, and then route it through redundant power paths. This redundancy is not optional. Every critical system follows an N+1 or even 2N design, meaning there is always backup capacity ready to take over instantly. Once power reaches the servers, heat becomes the enemy. Every computation produces heat, and overheating means failure. This is why server racks are arranged in hot aisle and cold aisle configurations. Cold air is pushed through the front of servers, heat exits from the back, and massive cooling systems, sometimes liquid-based, remove this heat from the building. In modern hyperscale data centers, cooling efficiency is measured using metrics like PUE because power wasted on cooling directly affects cost and scalability. Now comes the part most people never talk about: how data actually moves inside a data center. Servers don't talk randomly. They're connected through a hierarchical network fabric made of top-of-rack switches, aggregation switches, and core routers. When you load a website, your request doesn't hit one machine. It triggers a coordinated response across storage systems, compute nodes, load balancers, and edge caches. The system is designed so no single server matters. If one fails, traffic is instantly rerouted. Reliability is where data centers become engineering masterpieces. Power failures are handled by UPS systems and diesel generators that can start within seconds. Network failures are absorbed by redundant fiber paths. Hardware failures are expected, not feared. Software is built assuming machines will die. This philosophy, called fault tolerance, is the backbone of modern internet infrastructure. As demand exploded, data centers evolved again. Instead of one giant building, companies built distributed data centers across regions. This allows content to be served closer to users, reducing latency and improving reliability. What you call the cloud is actually thousands of geographically synchronized facilities, constantly replicating data and balancing load in real time. So when you stream a video, your data might be served from a center only a few kilometers away, while backups silently sync across continents in the background. That's not convenience. That's deliberate system design. Here's the crazy part. Data centers are designed assuming failure is guaranteed, not rare. A single large data center can consume as much power as a small city. Some facilities are built near oceans, inside mountains, or in freezing climates, not for secrecy, but for thermal efficiency. And the fastest parts of the internet aren't wireless at all. They're fiber cables, thinner than a hair, moving light across the planet.
Data centers are industrial systems, not just server rooms.
Power, cooling, and networking matter more than raw compute. Modern internet reliability comes from redundancy, not perfection. The cloud is physical, fragile, and incredibly engineered. Every digital action you take depends on this unseen infrastructure working flawlessly. If this video changed how you see the internet, subscribe to Behind the Byte. This channel is about exploring the hidden systems beneath everyday technology, the parts nobody shows you, but everything depends on. Drop a comment on what invisible tech you want us to break down next, and we'll see you in the next layer of the Byte.